In this interaction, we need to complete the square for the function y equals x squared plus 4x plus 3 using algebra tiles and then by using algebra. First, let's start with our algebra tiles. We need to determine how many x squared tiles we need, which of course is just 1. And let's drag that onto our work area. Next, we need to deal with our x tiles, which we have 4 of them. We'll drag 2 onto either of the two sides. Next, we need to take a look at our ones tiles. In this case, we need 3, and we'll drag them next to our workspace. Next, we need to determine how many tiles will it take to complete our square. Well, it looks to be 4, 2 by 2. And so we'll drag those inside. Next, in order to balance those 4 that we just dragged in, we're going to have to drag the same amount of negative tiles. So it'll be negative 4. And then from here we can see that these tiles are going to make a bunch of 0 pairs. 1 and negative 1 is 0, another 0, another 0, so we only have negative 1 tiles left. And we've completed our square, such that we have x plus 2, x plus 2, or x plus 2 all squared, minus 1. Let's try doing the same thing by using algebra. First thing we would do is we'd take a look at our middle term, or our b term right here, and we would divide it in half and then square it. So when we divide it in half, we'd have a 2x here, a 2x here. So we've divided it in half, then we'd square it, which would give us 2 squared, which is equal to 4. And so that's going to tell us what number goes right in this spot right here. I like to think of it as take that number, divide it in half, and square it. So we would be adding 4 and then subtracting 4. From here, our last term needs to get multiplied by our leading coefficient to move it outside of the brackets. So a negative 4 times a positive 1 will make us a negative 4 like so. And then from here, we can gather our like terms. Negative 4 plus 3 is negative 1. And we're now ready to complete our square. X squared plus 4x plus 4 is equivalent to saying x plus 2 all squared. And notice that this is the same solution that we had on the other side, such that we have x plus 2, or x plus 2 all squared, minus 1.